Hello viewers, welcome to Quick Coder. My name is Tulasi. Today's topic is how to search in a rotated and sorted array in Java. So let's get started. So before going into how to search in a rotated sorted array, I want to mention a few points to you. What is that is? So what is this rotated and sorted array mean? I want to say that. For example, this is my sorted array and I want to rotate this array two steps leftwards. Means for first step, what happens? This 2 comes left, 3 comes left, 4, 5 and 1. And what is the second time it happens? 3 comes here, 4 comes here, 5 comes here, 1 comes here, 2 comes here. So this is the rotated sorted array. And if you find at some point we have two sorted arrays with us. See 3, 4, 5, 1, 2. 1, 2 is one sorted array, 3, 4, 5 is another sorted array. So it is also known as partially sorted array. Okay. So if you find some pivot point, you can find the two sorted arrays here. See what is that pivot point here? This is the pivot point, which 9 to 37 is one sorted array, 3 to 7 is another sorted array. Okay. One sorry. Okay. Now, this is about the rotated and sorted array. So what is the thing here is I want to search in this rotated and sorted array. You may ask me that, so why you are doing all these things? We can search it in O of n time, no? By using or by traversing whole array like where I is equal to 0, I less than n, I plus plus. If my array of I is equal to key, then return I. So that's it. This is the simple uh, program to search where the key is. So this takes O of n time, but our task is to do it in O of log n time. And we also have another beautiful thing that this is sorted. Sorted means you can do it in binary search algorithm. Okay, you can do it in binary search algorithm. See here we have two sorted arrays, and the key you want to search is 4. You can simply up to 0 to this 0th index, first index, second index, third index, fourth index. You know that 3 is the pivot point. So you will search from only 0 to 2 binary search using binary search. So that's it, we can achieve it. But now what is the primary thing we have to find out? First, we have to find out the pivot point so that we will get two different sorted arrays. So let me clear this. Okay, now what is the first step? We have to find out the pivot point index. So how to find out the pivot point index? And this can be also find in log and time only. See how we will find. Very similar to binary search. So initially my L is pointing to 0 and my H is pointing to 11. Means L minus 1. N is length of the array. Now what I will do is initially this is the base condition that if my L is greater than H, I will return minus 1. So it is not greater than H, leave it. Now I want to find out the mid. Mid is nothing but L plus H by 2. If this is something I already explained in this binary search by the video where I explained binary search. You can watch that. And 0 plus 11 by 2, that is 5. So my mid will pointing to here. Now what I will do is, first of all, I will say, before explaining this part, I want to explain. So what is the pivot point here? This 3 is the pivot point. How will you find out that if the previous element is greater than this element, then we can say that this is the pivot point. See, for example, if you take this previous element is not greater than this element, so it is not pivot point. If you take this previous element is greater than pivot point, so that we can find out. So this is the another base condition that if my array of mid is greater than array of mid plus 1, then I can return this mid plus 1. 6 is the pivot point. But 28 is not greater than 32. No? So I will leave that and I will go to else condition. And what is the another thing now? Now I will compare this 28 with 9, the first element. I mean element at L. See here my 9 is less than or equal to 28. It is true. Means this is a sorted array because all in sorted arrays the elements goes increasing order. So here 9 is less than or equal to 28. So this is already the sorted array. Means I will have my pivot point in this range only. Now what I will do? I will simply take my L to mid plus 1. Means my L will come here. And now what is my mid? My mid is equal to, and again I will check is my L is greater than H or not. No, it is not greater than H. Now I will find out mid. Mid is equal to 6 plus 11 by 2, that is 17 by 2 is, my mid is here. Now I will find is my 3 is greater than, area of mid is greater than area of mid plus 1 or not. No, it is not greater than, means this is in some sorting order, sorted order here. Now what I will do, I will go to else condition. Now I will check this 3 with 32. Is my 32 is less than, is my 32 is less than or equal to 3? No. Condition fails. Means we can say that this is not in sorted array and the pivot point is also lies in this order only. Now what I will do is my h will come to mid minus 1. Mid minus 1 means here. Now again from starting onwards, is my L is greater than h? No. Now I will find out the mid. 6 plus 7 by 2, 13 by 2 is 6. Again my mid is pointing to here only. Now I will check is my mid is greater than mid plus 1 or not. So it is not greater than. I will go to else condition and I will check is my array of L, that is 32, is less than or equal to 32 or not. Yes. What will happen now? My L is mid plus 1 to H. It is in some sorted array. So here only will be there. Here will be my L. And now again, is my L is greater than H? No. I will find out the mid. The mid is also pointing to here. 7 plus 7 by 2, again 7. Now I will check is my array of mid is greater than array of mid plus 1 S. See 37 is greater than 3. Means here this is the pivot point. So I will return this 8. Return mid plus 1, that is mid is 7, no? 7 plus 1, 8. 8 will be returned. 8 is the pivot point. That's it. This is also can be done in log n time, of log n time. My first one is over. What is the first thing here? I want to find out the pivot point index. Okay, here I found out the pivot point index. So after explaining, before going to the next step, I want to clear something. Okay, I'm done with finding the pivot point index, that is 8. So what is the next step? I want to compare the given key 17 with array of 0. See why I'm comparing this with array of 0 means, see here, my 17 is my 9 is less than 17 or less than or equal to 17. Yes, 9 is less than or equal to 17. So by this you can say that, okay, this is in some sorted array part only because 9 is less than 17. No. In sorted array, the array goes by increasing order. Now it is okay. I will search from 0 to. So what happens here is in binary search function, I will pass this 0 and this pivot minus 1 and I will pass this array. I already explained how to do the binary search. Okay, you can check that video if you are not clear. Okay, binary search I will pass from 0 to pivot point minus 1 and array. Or else what happens if my key is 7? Now I will check with first element. Is my 9 is less than or equal to 7? No, it is not true. Means it is not in this part, it is in some other part. What is that part? From pivot to, what happens here? From pivot point to n minus 1, or else you can say, okay, n minus 1 and array. That's it. So we will compare, and if my area of 0 is less than or equal to key, then I will pass 0 pivot point minus 1 array, or else I will pass pivot to n minus 1 array. That's it. We are done with all 3 steps. Now let's start coding. I think you have clear idea about this. Now let's start coding. Okay, now let's start coding in my search. So let me first explain what is the input here. N and array and some key. So what is the index of this 10? 5, 0, 1, 2, 3, 4, 5. So 5 is the output. Now what is the first step? We have to find out the pivot point. No? Now I will write some other function like int pivot is equal to find pivot, and I will pass L, H and array. That's it. To implement this find pivot function, it also returns some integer. So int find pivot, in this I have low and I have high and I have some array. Let me take ARR. So what is the base conditions here? If my L is greater than H, then I want to just return -1. else I want to find the mid. It can be find like this. Equal to L plus H minus L by 2. If so, what is the another base condition? Like if my area of mid is greater than area of mid plus 1, then I can simply return this mid plus 1 value. I already explained this all this in the beginning of this video. And what is the else part here is if my array of L is something like less than or equal to array of mid, then I can simply do like this. Find pivot of means it is not in this range, it is in some other range like mid plus 1 to H and I will pass array. Otherwise, else find pivot of L to mid minus 1 array. That's it. That's it about the simple pivot point. Okay, I found the pivot point. So what is the next step? The next step is also very easy. What is the next step? We have to check is my like A of pivot is equal to key. If it is equal to key, then I just return pivot point. So what is the next steps? Or else if my something like what happens if there is no pivot point that is already the sorted array? There is no pivot point. For example, see I will explain with some other thing. So my given array is like this 1, 2, 3, 4, 5, 6. Here there is no pivot point. So simply my find pivot in method will return -1. So what happens? So these are the corner cases we have to think about it. So what happens in that case? So again we have to write like this also. First of all, what is the first condition is if my pivot is equal to -1, what happens? Simply binary, like I can do like this also, return binary search of from L to H. I'm searching from beginning to end. Okay, I'm searching from here to here because as there is no pivot point, this is also the fully sorted array. So I will pass this of L to H total array. Then I will perform the binary search. Okay. Okay, so this is the other condition. What is the other condition here? Like if my I want to compare it with the first element, no? What happens if my array of 0 is less than or equal to key? Then I just simply return this binary search of from where to where I will pass from L to pivot -1 and the total array. Or else return binary search of this pivot plus 1 because I already compared with pivot, no? No need to again pass pivot to H and I will pass this array. Okay. So sorry, I forgot to pass my key here. Okay. So I want to pass key also, no? And again. Okay, we are completed with the second step. Similarly, third step also. So the main remaining thing is we have to implement my binary search method also. It's very easy. Okay, I have int L, int H, int array, and int T. What is the first step is while my L is less than or equal to H, what happens here? Int mid is equal to L plus H minus L by 2. And if my array of mid is equal to key, then I just simply return that. Okay, return that mid index. Else if my array of mid is something greater than key, then I want to search in the first part, means which is equal to mid minus 1, or else my L is equal to mid plus 1. If there is no such element, at last I want to return minus 1. That's it. Okay, so this is the total one here. What is the first step? We found the find pivot, pivot index using find pivot method. And using that pivot, is if my pivot is equal to 1, then simply I'm passing whole array to the binary search. And if my array of pivot is equal to key itself, then I'm just simply doing like this, simply returning pivot point. I found the key. Or else if my array of 0 is less than or equal to key, I want to find it in the L2 pivot minus 1, or else pivot plus 1 to H. This is my binary search algorithm. So that's it, and let me compile this. Sorry, find pivot, something happens here. Okay, I think this. Okay. Compilation error, what happens? Array not found. Sorry, instead of passing A, I passed ARR. Now let me run. Compile and run. Missing return statement. Sorry if I really forget this return. Okay. Sorry for too many mistakes. Okay. It's saying that can your output is -1. Here, instead of mid plus 1, I wrote it outside. Okay, now let me run. It gave me correct answer now. 5, 6, 7, 8, 9, 10. 10 is it? Fifth index. Let me give some custom input. So this is my custom input, very big input. And what is our expected output? So this is the array. Let me show that. So this is the array, and what the element that I want to find out is, I want to find out 258. So 258 is at index of 54. See this? 258 is at index of 54. So my expected output is 54. Let me run this. It will give correct answer or not. As 54. It gave me the correct answer. So that's it about this video. And very sorry to say that I did many mistakes here. Simple mistakes. Instead of taking area of mid plus 1, I took area of mid plus 1 outside. And some I forgot this return statements. Okay, so very small mistakes. Instead of passing A, I just passed ARR. So don't do that mistakes. Okay, because of this some overwriting, I just did that. But don't do that type of mistakes. Okay, if you practice a lot, you will avoid that. And that's it about this video. Thank you, friends. Thank you for watching this video. The coming up video is Introduction to Stacks in Java. Okay, wait for this video and subscribe to my channel, Quick Coder, to get notified for the further videos. Thank you. Thank you for watching.